So those are your basic formulas on page 5. So really you only need to use these formulas, but then you might have to do a bit of deductive reasoning to solve some of the problems. So we'll do a couple more examples. These ones are a little more involved. Okay, so if I have to find the area of a shape that's not just a rectangle or a circle or a triangle, we kind of had this problem with that perimeter question. I can cut it up into nice shapes that are easy to do area. So looking at this, I can cut that up to make what? What kind of shapes?
Rectangles.
Yeah, rectangles. I could turn this into 2 rectangles. So where you cut it depends on whatever's easier. So I could cut it this way, right? In which case I'd have a rectangle here and a rectangle there. And if I find the 2 areas and add them together, I'll have it. Or I could cut it this way, right? And have a small one, a large one. It kind of depends on whatever's easier to do. If this is 28 from here to here, and this is 19, how far is this?
28 minus 19.
Yeah, so it would be 28 minus 19, which is 9, right? So that's 9. So that would be useful to me if I cut it this way. If I cut it this way, I would kind of need to know how far that is, right? If that's 15 and this is 7, how far is this?
8.
Yeah, it would be 15 minus 7, which is 8. So usually you'll have to do, we call that deductive reasoning, like taking what you know to deduce something else. And either way works. So it doesn't matter where you cut it. So let's say I do this one. So in which case, for all these things, I like to redraw them so I don't get confused about the numbers. I'm going to call this area 1. I'm going to call this area 2. So I'm going to redraw, just sketch. Here's my area 1. And it was 19 here, right?
Yeah.
And we figured out it was 8 there. So the area is just going to be 19 times 8. And I can use a calculator for that, which is 152. And it was meters, so it's meters squared, 152. Okay, and then I'm going to draw area 2. And we figured out that this was 9, right? So it's 9 there. And it's 15 here. And the reason I pull them apart and redraw them is so that I don't accidentally use the wrong numbers. Because there's other numbers in there, right? So I don't actually end up using the 7 or the 28. I only needed them at the beginning to find the missing parts. So then this is just going to be 9 times 15, which is 135 square meters. So my total area, which is area 1 plus area 2, would be 152 square meters plus 135 square meters. I got 287 square meters. And it should work out to the same thing if I cut it differently, right? If I cut it this way, made that a big long one, that would be 28 by 8. I'm just going to double check. And then the small little leftover piece here would have been 7 pi 9. So plus 7 by 9, and I get the same number. So it doesn't matter where you cut it as long as you figure out your dimensions. Okay? There's 2 ways to do this one. Either way, you'll get 287 square meters. Does that method make sense? a little bit of work at the beginning to find missing sides, pull it apart. You know, even though you can do it without redrawing the sketches, I highly recommend doing that because you're way less likely to make a mistake if you pull it apart. Okay. Okay, then this one here. Determining the area of a shaded part. It says determine the area of only the shaded part. So this is the shaded part, the grayish area. Well, if it was the whole rectangle, it would be pretty easy to do, right? If it was the whole rectangle, it would just be 32 times whatever this is, which is, it says the height's 20, so I guess this is 20. Okay? So the way you do these ones is you pretend it's the whole shape, and you subtract out the middle part. So the whole shape, if I was to draw a whole shaded rectangle, it would be 32, and this would be 20. So 32 times 20 is 640 square centimeters. So that's what it would be if I didn't have that white, like, missing triangle in there, right? So then I'm going to find so I'm going to subtract out the area of the triangle. So there was 20, and this is 24. So the area of the triangle, I'm too lazy to write triangle, so I just drew a triangle. Area of the triangle is 24 times 20, then divided by 2. So you get 240 square centimeters, right? So the area of the shaded part is equal to the area of the rectangle minus the area of the triangle. And for any of those kind of questions, and they'll come up again, that's how you do them. Find the area of the larger shape, subtract out anything in the middle. For like real life kind of questions on exams and stuff, usually these questions are landscaping questions, which means someone buys a house and they want to put down grass. You know, they want to buy sod. You know, you can buy grass. It's called sod. Have you ever seen sod? Yeah. Yeah, it comes in a roll, like, or it comes in pieces. Basically, like squares of grass with soil attached to it. And you can actually just drop it down. Then you water it in, eventually it turns into a lawn. It costs a lot of money. So if you had a new property and you had to put down grass for the first time, or if you just have a crappy yard and you want to like have nice grass, you can just, you know, tear out what you have and put down new sod. When you're planning it out on paper, it's pretty rare to have a yard that's a perfect rectangle, right? Usually there's junk in there. So maybe you have a patio, like bricks somewhere. Well, you can't sod that. So you'll draw that in your picture. Maybe you have a few trees, right? Well, you can't sod right to the tree stump, so you might have a bit of a circle around each tree. And so if you do what's called a plan view, like you're looking down on the yard, if you're trying to figure out how much sod to buy, you'd have to do this. You'd have you'd have something like, or if you're paying someone to do it, they would do an estimate for you. This is what they would do. They would do the math, right? So if you had a yard and you wanted it to be grass, but you had a tree here, right? A tree. Let's say you had another tree there, another one there. And let's say you had some kind of like maybe you had a bit of a patio here. So what they would do, they really want to know how much the shaded part, they would just measure they'd measure the outside dimensions of the yard to get what it would be if you didn't have stuff if it was just a big empty space, and they would subtract out pi r squared and another pi r squared and another pi r squared, and then and also subtract out the patio. So that's basically the work. That's the only kind of real life example I can think of where you would be doing this exact work for doing areas would be landscaping.
So they use some counters of each.
Yeah, yeah. Well, quite often if you're hiring like a real landscaping company, they'll usually put edging, that little plastic stuff, and they'll make it like a circle around a tree, especially if they're doing new sod, because it looks more finished rather than just having sod with an edge, right? Or what some people will do is they usually use edging though, or they might just cut a circle in the sod and then put in like mulch, like cedar mulch or something. You know, the little stuff that sits under the tree, makes it look nice. Yeah, that stuff. Yeah. Okay, so with this one, we just subtract them. We found the area of the whole rectangle was 32 by 20, so that's 640 square centimeters minus the area of a triangle, which was 240 square centimeters, so the area of just the shaded part is going to be 400 centimeters square. Can anybody see a different way to do this question? This is the easiest way to do it, but can you think of another way to do it? Well, what do we do in the question above? We cut it, yeah. So feasibly, we could take the shaded areas and cut it up into nice shapes. Like this is already a triangle. And if I cut it here, I could make another triangle and then a rectangle. And if I found those three pieces and added them together, I should get the same thing. The problem with that is it's a lot more work, and it may not be that easy to figure out what the missing lengths are. We have to use a lot of deductive reasoning. So subtracting out the piece in the middle is a lot faster. But you could probably break it up and figure it out. Like if this is 24 and that's 32, if I did 32 minus 24, I know that this is going to be 8 here. So the rectangle is not bad. It would be 8 by 20. There's 160 there, basically. I'm just going to pencil that in. This one is a lot trickier, though. It's a triangle, so the height is 20. That's the same. But it's kind of hard for me to figure out how far it is from here to here. Like, I don't really... Oh, well, maybe not. That's 24 here. Okay, that works. So this triangle is the same as that one. So this would be 24 by 20 divided by 2. And we found out that was 240. So 240 in there. And then we're left with this small triangle, which would be... We know the height is 20. How do I figure out how far this is? That's where I'm running into it. I'd run into trouble there, trying to figure out how far it is from here to here, right? So using this method, it would be, you may or may not be able to get there.
How would you?
Well, I would cheat and I would use trigonometry, which we're taking in the next unit. So maybe we should come back to it after we do the next unit. Because I don't see any other super easy way to do it. Do you? You're saying it should be 4? Why?
Because we have the size 8 and trig. Like that little corner piece that's cut off there, like the shaded part and like the white part, they're literally the same thing, but it's cut off at 20 or like the triangles. So like the other 4.
Oh no, this 20 is the height.
Yeah.
Yeah.
Like the other like shaded and white, like
here,
Yeah.
it's the same as this, right? This is the same as this, but how do you figure out what this is?
It should be the extra 4
Why is it 4?
because it's cut off at 20.
This triangle is 8, right? And the rectangle is 20.
The rectangle is... Yeah, I'm not sure why it would be. I mean, it might be 4. Maybe you could try it and see if you get the same thing. But I don't know that just looking at it you can guarantee. Also, sketches, you can't trust them. It may not be, like if I used a ruler, you may find that the numbers don't really match up with a proper measurement. So it, you know, it's one thing when you're doing, if you're doing like real blueprints or something, if you use graph paper and you measure everything perfectly, then it's easy that you can just count, right? You can actually, but if it's a sketch, it's harder to do that. But yeah, so if you were saying, if this was 4, then you would go 4 times 20, which would be 80, and then cut it in half, which would be 40. In which case, that plus 40 should give me 400, right? Yeah, and it doesn't work. Yeah, it doesn't look like it works. Because this we figured out was 20 by... Oh, yeah, we couldn't figure this out either. I don't know why we have that there. Because I don't know how far it is there. I mean, it looks like it's 20. Like, it does visually look like it's the same, 20 by 20. But I don't know that for sure. So, yeah. I think method 1, for the information we're given, I think we can only be sure of using it, doing it this way, subtracting out the space. Interesting. It's a puzzle. Yeah. But I think I'd be frustrated if I was trying to find for sure what this length was. So we say we don't have enough information, right? Without using another kind of mathematics. Okay, so that takes us to assignment 2. So these ones are all just use the formula, length times width, pi r squared, base times height divided by 2, length times width. You know, in a square, length and width are the same thing, but you just multiply them together. Pi r squared, base times height divided by 2. This one, you're going to cut it up. What do these ticks mean here? This tick and this tick, what does that mean? Yeah, it means they're the same. So whenever you see a diagram like this where you've got like a single tick there, it means they're the same length. Okay? Well, the only way these two can be the same length and add up to 12 is if they're both what?
6.
Yeah, so that tells you that they're both 6. Okay? If sometimes you'll see diagrams where there's like double ticks, you have to match those up, triple ticks, etc., etc. This one, we did this before for perimeter, but now you can do it for area. What 2 shapes can I make out of that?
Circle.
Yeah, if I take that half circle and this half circle and put them together, I could make a single circle, and then this would be a rectangle. And I could use the 2 formulas, length times width and then the pi r squared, add them together. Okay? And then eventually, you'll get to the ones where you need to find the area of the whole shape, subtract out the part in the middle. So this would be the area of the square minus the area of the circle. This one's going to be the area of the circle minus the area of the square. This one's messed up. I don't know. I think this one's a lot of work. This one you might have to break it up in pieces and subtract out this triangle. Yeah, because there's an extra little piece here. This one is the area of the square minus 4 circles. Okay? So you're going to subtract out the pi r squared 4 times. This one's going to be a bit of work as well because it doesn't tell you what the radius is. You're going to have to use deductive reasoning to find that. Right? What's a radius again? It's the distance from the center to the edge, right? So from here to here, that's a radius. And there's another one. And there's another one. And there's another one. How many are there?
Should be 1.5.
Right. If there's 4 radiuses and the whole length is 6, 6 divided by 4 would make 1.5. So that's what you're going to use for this one. So again, there's a bit of work there, deductive reasoning, to find the missing numbers, and then you do the work. And this one, again, a real life scenario, although I don't know any painters that actually do the measurements that precise. They're saying you want to paint this wall, but there's windows on it. How much paint do you need? So you're going to, like, area of the wall minus these windows. Okay?
All the work just for paint.
Yeah. I mean, paint's a little flexible, so in real life, they estimate how much paint they need, they buy extra, and then they just use it. Now, however, if a can of paint cost $1,000, people would do the math. Okay? They would do the math and they'd get it precise because they don't want to waste any. All right? If it was gold or something, you're applying liquid gold to the walls, then you would definitely do the math. I think in real life you would just buy extra paint, just buy enough paint for the wall and just don't paint the windows. But you know, it's the same kind of work as the landscaping. Landscaping, they actually do the math. But okay, so you have time to work on these. Complete assignment 2.